Hi, my name is Audrey Olenski and I'm going to be presenting my Lab 3 experiment about finding the magnetic field of a bar magnet. I'm going to begin by discussing the background of this lab. Our goal in doing this experiment was to measure and observe the magnetic field created by a bar magnet and to determine the impact of distance on the magnetic field. Our purpose in doing this is to build a better understanding of magnetic fields through a visual representation. Additionally, the purpose in doing this lab is to find the relationship between distance and the magnitude of the magnetic field. Some key physics concepts that are used in this lab are Biot-Savart's law and the distance dependence equation for magnetic fields. These equations are essential for understanding the purpose and goals just mentioned and will be utilized in the calculations section of this presentation. This experiment had a multi-part setup and process for measuring the magnetic field. To begin, I had to download a magnetometer app on my phone that allows me to see the net magnetic field and the magnetic field in X, Y, and Z directions. The phone was then placed in an area where there was no magnetic interference other than the Earth's magnetic field. This was done by avoiding metal furniture and other electronics. To find the spot, I researched the magnetic field of my location and found it to be around 49 microteslas. I then placed the phone where the net magnetic field was equal to this and the X component was 0. Then, to find the sensor on the phone, the bar magnet seen at left was moved up and down vertically, like seen in the left picture, to a point where the absolute value of the X component was at a maximum and the Y component was at a minimum. The phone was then turned and the magnet was moving along the short side of the phone to a point where the X component was a minimum and the Y component was a maximum. The place where these 2 points met was the location of the sensor, which was at the upper left of my phone. To collect the data shown here, I found how far the magnet had to be from the phone to produce an X component of the magnetic field that was equal to 20, 70, 120, 170, and 220 microteslas. The average of 3 trials at each X component magnitude and their corresponding net magnetic field were shown on the bottom and then plotted on the right side. The slope of this graph, seen in the equation on the plot, will be important for our calculations. These are my calculations for finding the magnitude of the magnetic moment. To do this, I use the distance dependence equation mentioned previously and shown on the right that states that the natural log of the magnitude of the magnetic field equals the natural log of k plus the natural log of r times n, the slope. Starting with the equation of the trend line from my graph, I found the slope of the graph n to be negative 2.9416. I also used my known values of the x component of the magnetic field, which is the second component of the trendline equation, and the value of r as 1 meter. To solve for the magnetic moment, I first solved for k using the second equation shown on the right, then plugged in all of my values into the bottom equation on the left. From here, I found my magnetic moment to be 2.1575 ampere meters squared. Shown here is part of the GlowScript code used to make the visual model. First, I created a function for the magnetic field representing what the field would be due to a dipole at a specific location. I then used 2 axis and 4 perpendicular locations in the code that were used as observation locations for creating the arrows. Each of these locations had a magnetic field as shown in the top right section of code. The remainder of the code here finds the average magnitude of the field at an observation location 45 degrees from the axis. Here, the d perpendicular value from my data was used to create the arrow representing the field at the observation location. Lastly, the code prints out this value. Here you can see the visual model created by this code. The purple arrows show the magnetic field calculated on 2 on-axis locations. The green arrow shows the magnetic field at a location 45 degrees from the axis. Lastly, the blue arrows represent the magnetic field perpendicular to the axis. While you can only see 3 arrows, there are actually 4 as we created in the code. Because they all have the same magnitude and direction, the 2 arrows in the middle overlap. These arrows all come together to build a visual that helps us better see and understand how the magnetic field works. To conclude, I'm going to discuss a few questions to consider given our findings. If I hadn't oriented the experiment to account for magnetic north, and I had instead just laid the meter stick at an intermediate angle, my results would have been quite different. By not accounting for magnetic north, I make it impossible to know which part of my data is due to the Earth's magnetic field and which part is due to the bar's bar magnet's magnetic field. If I had used 2 magnets instead of just 1, the magnetic field would have been much greater and the distance much smaller. This concludes my discussion of Lab 3. Thanks for watching.